And now, in this lecture, we'll find out the radius of a circle. In the drawing, we have the right triangle, triangle ABC. Inside this right triangle, we have this circle. And our mission is to find out the radius of this circle. In addition, we know that line segment AES, this line segment AES equals to 1 unit in its length. Line segment ST equals to 3 units in its length. And finally, this line segment DC equals to 2 times 4 to 3 units in its length. And this is angle ABC, that is a right angle. Again, our mission is to find out the radius of this circle. So, first of all, we define the center of this circle. The center of this circle, this point is O. The point of tendency of tangent AB with this circle is P, and the point of tendency of tangent BC with this circle is Q. We define the radius of this circle as x. So I write it down. The radius of this circle equals to x according to our definition. In the next step, we join points O and Q together by a straight line. Point O is the center of the circle, point Q is a point on the circle itself, therefore OQ is the radius of the circle that is equal to x according to our definition. You can implement here rule 1. Repeat quickly on rule 1. Commit to rule 1. The tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle and we have, this is tangent AB. This is tangent to this circle here at this point, point M. Point M is the point of tendency of tangent AB with this circle. And we have the radius OM that is equal to R, so the radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever your radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, this angle also equals to 90 degrees. You can actually implement rule 1 in our drawing. Why? Because in our drawing, we have the radius OQ of this circle that is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. Line segment OP is the radius of this circle that is equal to x, according to our definition. Again, we have the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. In the next step, we'll focus on this quadrangle POBQ. Inside this quadrangle POBQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, the missing fourth angle here must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside the quadrilateral POBQ to 360 degrees, the missing angle here must be equal to 90 degrees in its size. So inside the quadrilateral POBQ we have 4 right angles. Any quadrilateral that has 4 right angles must be this rectangle not a square. So we relate to this quadrilateral POBQ as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle POQB, side PO must be equal to the opposite side BQ. But PO equals to X, therefore BQ must be also equal to X because they are equal to each other. Likewise, in the same rectangle POBQ, side OQ must be equal to the opposite side PB. But OQ equals to X, therefore PB must be also equal to X. So I actually found out that for the other POBQ is not a rectangle but a square. In the next step, we define the length of this 97 AB as A. And we define the length of this 97 QC as B. Here we can implement in our drawing rule 10. We'll be the rule 10. According to rule 10 is true in any circle. So in any circle, if AB is any chord, here AB could be any chord in this circle, and we have tangent PT, this is tangent PT, that is tangent to this circle, here this point, point T. Then in this drawing, the following equation is true. That PT square equals to PA times PB. Again, PT square equals to PA times PB. We can actually implement rule 10 in our drawing. Why? Because in our drawing, if you focus at this point, point A, from point A we have tangent AP to this circle, tangent AP is tangent to this circle, here at this point P. And we have also, this is called TS, that it touches the extended chord TS touches point A here. So all the requirements of rule 10 are met, and therefore we can implement here rule 10. According to rule 10, AP square equals to AS times AT. Again, AP square equals to AS times AT. So I write it down. If you focus on the common external point, point A, according to rule 10, AP square equals to AS times AT. Repeat again. According to rule 10, if you focus on the common external point, point A, AP square equals to AS times AT. AP equals to A according to our definition, therefore AP square is A square, so A square equals to AS. AS is 1 times 80. 80 in total equals to 1 plus 3. Okay, 80 equals to 1 plus 3. So if we just found out actually that a squared equals to 1 times 1 plus 3. That is to say, a squared equals to 1 times 1 plus 3. 1 plus 3 is 4, and 4 times 1 is 4. So a squared equals to 4. Here we take a root out of this equation, and finally we get that a equals to the square root of 4, that is 2. So we found out that a equals to 2 units in its length, so I write it down. A equals to 2 units in its length. Likewise, we focus on the common external point, point C. From the common external point, point C, we have tangent CQ that is tangent to this second point Q, and we have chord ST, that the extended chord ST, such as point C here. So all the requirements of rule 10 are met, are satisfied, and therefore we can implement here rule 10. According to rule 10, we will get that CQ squared equals to CT times CS. Okay, again, if you focus on the common external point, point P, according to rule 10, we get that CQ squared equals to CT times CS. CQ is B according to our definition, therefore CQ squared is B squared, so B squared equals to CT. CT is 2 times square root of 4, 2 times square root of 3 times CS. CS in total equals to 3 plus 2 times square root of 3. Again, CS in total, or SC in total equals to 3 plus 2 times square root of 3. And so we found out that B squared equals to 2 times square root of 3 times 3 plus 2 times square root of 3. Here we open the brackets on this side of the equation, and we get that B squared equals to 3 times 2 times square root of 3 plus 2 times square root of 3 times 2 times square root of 3. In total it is equals to 12. Why? Because 2 times 2 is 4, and square root of 3 times square root of 3 is 3, and 4 times 3 is 12. So in total, 2 times square root of 3 times 2 times square root of 3 equals to 12. If we found out actually that B squared equals to 3 times 2 times square root of 3 plus 12. Here we substitute 12 by 9 times 3, and we get that B squared equals to plus 9 plus 3 plus 2 times 3 times square root of 3. So this equation is very similar to the algebraic identity that states that a squared plus b squared plus 2 times a times b equals to a plus b squared. In our equation, a equals to 3 and b equals to the square root of 3. So therefore a square is 9 plus b square is equal to 3 squared, it is 3, plus 2 times a times b is 2 times 3 times equal to 3. So this expression actually 9 plus 3 plus 2 times 3 times equal to 3 is very similar to the expression a square plus b square plus 2 times ab, but because of the fact that a square plus b square plus 2 times ab equals to a plus b square, we get that 9 plus 3 plus 2 times 3 times equal to 3 will be equal to a plus b square. A is 3 plus b, that is equal to 3 squared. In conclusion, we actually found out that 3 plus equal to 3 squared equals to 9 plus 3 plus 2 times 3 times equal to 3. So therefore b squared equals to 9 plus 3 plus 2 times equal to plus 2 times 3 times equal to 3. But because of the fact that 9 plus 3 times 9 plus 3 times 9 plus 3 plus 2 times 3 times equal to 3 equals to 3 plus equal to 3 square, it means that b square will be equal to 3 plus equal to 3 square. So here we take a root out of this equation, and finally we get that b equals to 3 plus equal to 3. 3 plus equal to 3, so it is 3 plus equal to 3. Square root of 3 is 1.732, so 3 plus 1.732 equals to 4.732. In conclusion, I actually found out that b equals to 4.732 units. So I write it down in the original drawing. Here, b equals to 4.732 units. And we already found out that a equals to 2. So in the next step, we will implement the Pythagoras theorem of this right big triangle, triangle ABC. In the right triangle, triangle ABC, here by PT is the evaluation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle, triangle ABC is AC, therefore the square of the hypotenuse is AC square. And AC square must be equal to AB square plus BC square. Repeat again. According to the Pythagoras theorem, in the right triangle ABC, AC square equals to AB square plus BC square. What is the length of the hypotenuse AC? AC in total equals to 1 plus 3, that is 4, plus 2 times equal to 3. So in total, AC equals to 4 plus 2 times equal to 3. So I write it down. AC equals to 4 plus 2 times equal to 3. Therefore, AC square will be equal to 4 plus 2 times equal to 3 square. And it is equals to AB square. AB in total equals to x plus 2. Therefore, AB square is x plus 2 square plus BC square. BC equals to x plus 4.732, and therefore BC square will be equal to x plus 4.732 square. The conclusion found out actually that according to the Pythagoras theorem, 4 plus 2 times equal to 3 square equals to x plus 2 square plus x plus 4.732 square. So what is the value of this expression 4 plus 2 times square root of 3 square? Actually it is equals to 4 plus 2 times square root of 3 square equals to 'in total this expression equals to 55.7128. So I write it down. This expression 3 plus 2 times root of 3 square in total equals to 55.7128. And it is equals to x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2 is 4x, plus x plus 7, x plus 4.732 square equals to x square plus 4.732 square is equals to 22.3918 plus 2 times x times 4.732 is equals to 9.464x. So in this side of the equation we have 55.7128 and it is equals to x squared plus x squared is 2x squared. We have here 4 plus 22.3918 equals to 26.3918, and 4x plus 9.464x equals to 13.464x. Here we subtract 55.7128 from this equation and we get that in this side of the equation we left with nothing, so it is 0. This is equals to 2 times x squared and 26.3918 minus 55.712 is equals to 26 minus 26 is actually equals to, do it again, 26 3918 minus 55.712 is equals to minus 29.314 plus 13.464x. So here we divide this quadratic equation by 2 and we get that x squared and minus 29.314 over 2 is minus 14.66 and 13.464 over 2 equals to plus 6.732x and it equals to 0. So we have here a quadratic equation. The quadratic equation is as follows: x squared plus 6.732x minus 14.66 equals to 0. Again, this is a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared on 4 times a times c over 2a. In our specific quadratic equation, the coefficient a is 1, the coefficient b is 6.732, and the coefficient c is minus 14.66. Repeat again. Now a specific quadratic equation: x squared plus 6.732x minus 4.66 equals to 0. The coefficient a is 1, the coefficient b is 6.732, and the coefficient c, the coefficient c equals to minus 14.16. In the next step, we put this data inside the general formula for x, and we find out the value of the values of x. I will remind to you that x is the radius of this circle. So x equals to minus b. B equals to 6.732. Therefore, minus b is minus 6.732 plus minus square root of b squared. So b is 6.732, therefore b squared is 6.732 squared. That is actually equals to 45.3198 minus 4 times a times c. So minus 4 times a is 1, so minus 4 times 1 is minus 4, and minus 4 times C, that is minus 14.16, is equals to plus plus 58.64. So inside the root we have 58 plus 64 divided by 2a. A is 1, so 2 times a is 2 times 1, that is 2. So conclusion actually found out that x equals to minus 6.732 plus minus, and inside the root we have 58.66 plus 45.3198. It is equal to 103.9598 divided by 2. So x equals to minus 6.732 plus minus, and the square root of 103.95, the square root of 103.9598 is equals to 10.196 divided by 2. So here we have two solutions for x. The first solution for x is that x equals to minus 6.732 minus 10.196 divided by 2. So this expression is a negative number, and x is a radius is a length, and as a length it cannot be a negative number. So we cancel the solution, and we left only the second solution that is possible for x. X actually equals to minus 6.732 plus 10.196 divided by 2. So x equals to 10.196 minus 6.732 is equals to 3.464 divided by 2. So we actually found out that x equals to 3.464 over 2. This is actually equals to 1.732. Repeat again, actually found out that x, that is the radius of the circle, is equals to 1.732 units. And this is the answer to the question. Repeat again. The radius x of this circle is equals to 1.732 units. So in the next step, I'll summarize the lecture. So in this lecture, we found out the radius of this circle. This circle is located inside this right triangle ABC. In addition, we know that line segment AS equals to 1 unit in its length. This is line segment ST is equal to 3 units in its length. And this line segment TC equals to 2 times equal to 3 units in its length. And our mission is to find out the radius of this circle. So in the first step, we actually define the center of this circle, this point as O, and we define the radius of this circle as x. Here, the radius of this circle equals to x according to our definition. We join points O and Q together by a straight line. Point O is the center of the circle, point Q is the point of the circle itself, therefore OQ is the radius of the circle that is equal to x according to our definition. We have the radius OQ that is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule 1. We join points O and P together by a straight line. OP is the radius of this angle that is equal to x. The radius OP is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to PO. If AB is perpendicular to the radius PO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. So inside the quadrangle POBQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total the sum of those 4 angles must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees in its size. So inside the quadrangle POBQ we have 4 right angles. And you know that any quadrangle that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrangle POBQ as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side PO must be equal to the opposite side BQ. But PO is x, therefore BQ must be also equal to x. Likewise, in rectangle POQB, side OQ must be equal to the opposite side PB, but OQ is x, therefore PB must be also equal to x. In conclusion, we can find out that quadrangle POQB is not a rectangle but a square. The next step, we define the length of this line segment AB as A, and we define the length of this line segment QC as B. And then we implemented here rule 10. Repeat quickly on rule 10. According to rule 10, first of all, rule 10 is true in any circle. So in any circle, if AB is a curve, and we have here tangent PT that is tangent to this circle, here at point T is the point of tendency of tangent PT with this circle. So in this drawing, the following equation will be true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. Okay. We can actually implement rule 10 in our drawing. Why? Because in our drawing, if we focus on the common standpoint point A, this point A, on the common standpoint point A, we have tangent AP to this circle, and we have chord TS that if we, when we extend it, we get here line segment TA. So all the requirements of rule 10 are satisfied, therefore we can implement rule 10. According to rule 10, AP square equals to AS times AT. Again, AP square equals to AS times AT. Repeat again. According to rule 10, if you focus on the common standpoint point A, AP square equals to AS times AT. So AP is 8, therefore AP square is A square. And it is equals to AS times AT. AS is 1 and AT is 1 plus 3 again. AS is 1 and AT equals to 1 plus 3. So in conclusion, we actually found out that A squared equals to 1 times 1 plus 3. 1 plus 3 is 4, so A squared equals to 4. We took out all of the equations and finally found out that A equals to the square root of 4, that is 2. A equals to 2. Here A equals to 2. Likewise, we can implement rule 10 in our domain. If we focus on point C, here at point C, from point C we have tangent CQ to this circle. Yeah. From point C we have tangent CQ to this circle. And we have called ST that extended until point C. Therefore we can implement here rule 10. According to rule 10, we get that CQ square equals to CT times CS. Again, CQ square equals to CT times CS. Let's again. If we focus at point C and we implement rule 10 in our drawing. According to rule 10, we get that CQ square equals to CT times CS. CQ is B, therefore CQ square is B square. And it is equals to CT. CT is 2 times square root of 3 times CS. CS is 3 plus 2 times square root of 3. Okay. So here we open the brackets. And we get that B square equals to 3 times 2 times square root of 3, and 2 times square root of 3 times 2 times square root of 3 is 12. So in conclusion, we found out actually that B square equals to 3 times 2 times square root of 3 plus 12. Then we substitute here 12 by 9 times 3, so in conclusion, we found out actually that B square equals to 9 plus 3 plus 2 times 3 times square root of 3. So this expression is very similar to the expression that A squared plus B squared plus 2 times AB, and it is equals to A plus B squared. Okay. In our equation, A equals to 3 and B equals to the square root of 3. So A squared is 3 squared, that is 9, plus B squared, that is square root of 3 squared, that is 3, plus 2 times AB. 2 times AB is 2 times 3 times square root of 3. Okay, so this expression in total equals to A plus B squared, when A is 3 and B is square root of 3. So we found out actually that B squared equals to 3 plus square root of 3 squared. Here we took out all of this equation and finally found out that B equals to 3 plus square root of 3, B equals to 3 plus square root of 3. So B equals to 3 plus square root of 3. Square root of 3 is 1.72, and 3 plus 1.732 equals to 4.732. In conclusion, we found out actually that this value at Q3 is equal to B, it is equal to 4.732 units. And we already found out that A equals to 2. So in the next step, we implemented the Pythagoras theorem on this right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC squared, so AC squared must be equal to AB squared plus BC squared. Repeat again, according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. So what is the length of AC? AC 1 plus 4, 1 plus 3, that is 4, plus 2 times 4 to 3. So in total, AC equals to 4 plus 2 times 4 to 3. Okay. So, repeat again, AC in total equals to 4 plus 2 times 4 to 3, therefore AC squared is 4 plus 2 times 4 to 3 squared. And it must be equal to AB squared. AB is x plus 2, therefore AB squared is x plus 2 squared, plus BC squared. BC is x plus 4.732, therefore BC squared is x plus 4.732 squared. Repeat again. BC squared is x plus 4.732 squared. So in conclusion, we found out that 4 plus 2 times 4 to 3 square equals to x plus 2 square plus x plus 4.732 square. 4 plus 2 times 4 to 3 square equals to 55.7128, and x plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 square is equals to x square plus 4.732 square, that is 22.3918. Okay. Plus 2 times x times 4.732. It's actually 9.46 for x. So here we have x squared plus x squared is 2x squared, and we have also 4 plus 22.3918, that is 26.3918, plus 9.46 4 plus 4x is 13.464x. So conclusion, we actually found out that 55.3128 equals to 2x squared plus 26.3918 plus 13.464x. Here we subtracted 55.7128 from this equation, and finally found out that 2x squared equals to 26.3918 minus 55.128 is equals to minus 29.314 plus 13.464x. And we found out that 2x squared minus 29.314 plus 13.464x equals to 0. Here we divided this equation by 2, and finally found out that x squared equals to 29.314 over 2 is 14.66, and plus 13.468x over 2 is 6.732x. So in conclusion, we have the quadratic equation x squared plus 6.732x plus 14.66 equals to 0. So this is the quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And find out the value of x according to the following formula. According to the formula that states that x equals to minus b plus 1 square root of 3 square minus 4 times ac over 2a. Now a specific quadratic equation, a equals to 1, b equals to 6.732, and c equals to minus 14.66. So we put the data inside the general formula for x and found out the value of the values of x. X equals to minus b, b is 6.732, therefore minus b is minus 6.732 plus minus square root of b square. B is 6.732, therefore b square is 6.732 squared, that is 45.3198 minus 4 times A times C. So it is minus 4 times A is minus 4, minus 4 times 1 is minus 4, times C, that is minus 14.66. So, and minus 4 times minus 14.66 is plus 58.64 divided by 2. So inside the root we have 55.3198 plus 58.64, that is 103.9590. So we have here two solutions that are possible for x. The first solution for x is the negative solution, so we cancel the negative solution because of the fact that x is the left, and the left cannot be a negative number. So we have only the second solution for x, that x equals to 6.732 plus 10.196 divided by 2. And it again, we left only the second solution that is possible for x. The second solution for x is that x equals to 16.732 plus 13.196 divided by 2. And 6.732 plus 10.16 equals to minus 3.464 divided by 2. And 3.464 over 2 is 1.732. In conclusion, actually found out that x, that is the radius of this circle, equals to 1.732 units in its length. Okay, thank you very much.